As promised, we're going to look at how to balance equations properly in section 6.3 today. So what is a chemical equation? This is just going to review chapter 6.1 and 6.2. An equation is a shorthand way of writing a chemical reaction. And reactants are found on the left, products are on the right. And this is just an example. So our reactants on the left, the arrow always points to the products. And as we talked about in class, this is the difference between Facebooking an entire conversation that went on as opposed to just tweeting about it and actually getting the point across. So this is what we would tweet. So that now that you know how to write out the equation, we have to look at how to balance the equation, because we know that atoms cannot be created or destroyed in a chemical reaction, only changed in form. So whatever we start off with on the left-hand side, on the reactant side, must show up with the same number of that type of atoms on the right-hand side. Not necessarily in the that type of a compound, but it has to show up, that element has to show up in the same number on the right-hand side of the equation. So the question is, how are we going to accomplish this? Well, we're going to do this by changing the coefficients in front of the substances in the equation. So here's some tips for balancing equations before we get started. If you'll balance your metals first, balance nonmetals except for hydrogen and oxygen second. If there's polyatomic ions, we sometimes, and they're conserved as a unit, so they're the same polyatomic ion on the left as there is on the right, then we can balance them as a unit, and that helps. And then balance any remaining hydrogens and oxygens. All right, so here's where I told you you needed to bring an ink pen and a pencil. The reason being, when you write out your reaction like this is written out here, it should always be written in ink. The reason being, if this is written in ink already, for me to come in to put something extra to alter this is going to seem really strange. I can't erase it if it's written in ink, and it's something I should never do. So we're going to make sure that we have the reaction itself written in ink so that we can't erase it and we don't change it. Just like in math, we have coefficients. So in math, if you have, let's say, xy squared, what is the coefficient? So the coefficient's the number out in front, and if there's nothing written, it's assumed to be a 1. It's the same way in a chemical reaction. So while xy or xy squared is the same thing as 1xy squared, 1 NaCl and NaCl are identical. We're just going to do this by doing an example so that you get to see how it works. I'm going to change ink colors just so you can see the difference between what you can mess with and what you can't mess with, and we're going to go from there. So what we have to do is we have to add up how many of each type of element we have on each side of the arrow. So that's why I drew this divider here. And then this is the steel method. So if you'll just follow my method as we go through this for the next day or so, you're going to be able to see some of this without having to do so much of the written out part, but just follow what I'm doing for now. So we're going to start off by writing down each element that we have and how many we have of each element. So I just go from left to right and write down the compounds. And you need to come over here, and also I would keep with the same order. So make sure that they have the same element on the left hand or right hand side as you do on your left, and then keep them in order. So do I have sodium over here? I do. So I'm going to write down sodium. Do I have chlorine? I do. Do I have beryllium? I do. And do I have fluorine? And I do. Now, this may seem silly to double check this, but sometimes we don't completely write out reactions like we should, and that can cause us to not have all of the compounds down that we need, so that we're not going to, sometimes don't have the same elements on the left as we do on the right. If you have different elements on the left than you do on the right and not the same ones, that's a red flag that you need to back up because something you've done is wrong in writing out the reaction. The next thing we do is look and see how many of each element we already have. So we have sodium, and there's a coefficient of 1 out here, and there's a subscript of nothing here, which is a 1, so we have 1 sodium. We have 1 chlorine, so 1 times 1 is 1. We have 1 beryllium, 1 times 1 is 1. And we have 2 fluorine, 2 times 1 is 2. On the other side, we have 1 sodium. We have 2 chlorine, 2 times 1 is 2. We have 1 beryllium, 1 times 1 is 1, and fluorine is 1 as well. So we look at it from this point, we say, okay, are we balanced? And the answer is obviously no, because we don't have equal numbers of each element on both sides. We have the same number of sodium and the same number of beryllium, but if you notice, we have different numbers of chlorine and fluorine. So we need to make sure that we have the same number of everything on both sides. So we're going to look at it and say, okay, what makes sense? And here's where the trial and error comes in. You need to make sure that you understand that if you haven't balanced a reaction after working on it for a little bit, number one, you have written it down incorrectly, and you need to go back and make sure that you have it written down correctly so you don't have an issue that way that's causing you not to balance it. And if that's all in order, the second thing you need to look at is you just working on it harder, because if it's written out correctly up here and it's a real chemical reaction, it can be balanced. If you stop before you have it balanced, it's because you've given up on it. That's one thing you can't do, is give up on it. So if you have a lot of trouble with one, I suggest that you skip past it, go ahead and do a couple of others, and then come back to it. Sometimes writing it on a separate sheet of paper by itself and redoing this initial part completely without any kind of marks or erasers from the last time that you did it, sometimes you can catch your mistakes and easily see how to balance it that way. So when I look at this, I look at our first problem, so it's chlorine and fluorine, and I look up here and say, okay, well, I know I have 1 here and 2 here, so if I change this coefficient to a 2, that would change my chlorine number to 2, which would mean that the chlorines now match. Sodium also was changed, though. By adding the coefficient 2 out front, that means I now have 2 sodium. So that causes me an issue because my sodiums are no longer balanced. Well, let's go ahead and fix that real quick and put a coefficient of 2 in front of sodium, which changes this to 2, and inadvertently that changes the number of fluorine to 2. And now you see that we have 2 sodium on both sides, 2 fluorine on both sides, 1 beryllium, and then 2 fluorine. So this is considered a balanced equation. And when we go over this in class, when I ask you to look at your coefficients, I would read the answer to this one as 2, 1, 2, 1. You don't have to have a 1 in these blanks because the coefficient of 1 is understood. Let's take a look at this reaction. We're going to go about it the same way. We're going to pick a different color and I'll put a line here to divide the reactants from the products. Write down each element that is involved on both sides. And one of the things that it told you in the beginning was that if you have a polyatomic ion that is the same polyatomic ion on this side as it is on this side, in other words, it didn't get broken up into elements. So here's PO4 on this side and PO4 as a unit on this side, then we can balance it as a unit as well. So we can do it like this. We can say PO4 and come over here. We have iron on this side. We have chlorine. We have beryllium. And we have the phosphate ion. So we can kind of balance it as a whole, as opposed to dividing it up into 2 separate elements, phosphorus and oxygen. So I look at this and I write down what I have. I have 1 iron, I have 3 chlorine, I have 3 beryllium, and I have 2 units of phosphate. Over here I have 1 iron, I have 2 chlorine, I have 1 beryllium, and I have 1 phosphate. So when I look at this, I can look at it and say, okay, my iron is okay. My beryllium, let's look at it. It's my other metal, so let's look and see if we can't balance the beryllium. So putting the coefficient 3 in front of BeCl2 changes the beryllium to 3 and the chlorine to 6. So now beryllium's okay, but my chlorine's not. The good thing about the chlorine is we've noticed we have 6 on this side and 3 on this side. So I can come over here and put a 2 out front. That's going to change iron to 2, and it changes my chlorine to 6 because we have multiples. So I look at this, I'm getting a little bit closer. I notice that I don't have enough iron on this side, so I go put a 2 in front because I have 2 iron here. That changes this to 2. And if you notice, that also is going to take this phosphate to 2. So there's 2 full units, 2 of the phosphorus and then 8 of the oxygen, which would be 2 full units. And when I do that, you'll notice that my overall reaction is balanced. So my answer for this one would be 2, 1, 3, 2. I've just flipped through my slides and found a couple of practice problems that we could look at. And I'm not going to spend time balancing them on the video, but the problems that you have for homework or for classwork are going to help you just practice and practice and practice balancing equations. A couple things that I want to bring to mind here. If we look here at this reaction number 8, I want you to notice that SO4, sulfate, and sulfate are the same on both sides as far as the same unit. So they're still traveling together as a polyatomic ion, which means that you can balance them as a unit. So we can write down SO4 as one of mine here. However, you cannot do that with hydroxide because you notice hydroxide is on the left, but hydroxide isn't on the right. So you have to break that up. Another thing is, if we look at, let's do hydrogen, we'll do sulfate, we'll do calcium, we'll do oxygen, and we'll do hydrogen. Let's look at the number we have on this side of each, and I'll show you how I come up with them. Notice that hydrogen and hydrogen are the same, so we're going to be adding those together. So we have 2 hydrogen here, and we have 2 times 1 times 1, so 2 hydrogen there. So the number of hydrogen on this side is 4. The number of sulfates is 1. The number of calciums is 1. And the number of oxygens is 2 times 1 times 1, which is 2. So I just wanted to show you an example of when you had parentheses involved and a polyatomic that transferred and one that didn't. So practice makes perfect, and you can ask any questions about these in class, and hopefully this lecture helps with you understanding how to begin to balance equations.